Okay, so I'm just going to walk through this. I've sent you the file so you can follow through, or you can practice these, or just watch as we go to see if you can catch on with the significant figures and rounding. So one thing that I think is kind of like difficult to understand is when you think of significant, significant makes you think it's important, right? So if I think of something significant, it's important to me. Well, significant figures are really just measured numbers. That's the way to think about them. Numbers 1 through 9 are always going to be measured numbers in a value. So if I have a 67.5 kilogram patient, all of those three values are measured. So I wouldn't just say that this person weighs 67.5000 kilograms, because that would indicate that I would have to have a scale that measured all the way to 4 decimal places. Instead, most of the beds, they just measure in terms of 1/10 of a kilogram. And so those three, I'm not just going to randomly add zeros on, because that adds to the exactness of the number. So if you see like 12.8965, all of those are considered significant figures because those would all be measured all the way down to those 4 decimal places. So that would give me 6. 15,968.3, I measured down to the nearest 1/10 of a decimal place, but all of those are non-zero numbers. And so that's also going to have 6 significant figures. So it's really just the zeros that are the challenge. So remember that zeros in front are never significant. So if I said a teaspoon of salt weighs 0.00058 kilograms, the 5 and the 8 are significant, but the zeros out front are just showing me how small that number is. And another way to think about it is if I changed this to scientific notation would change that number to, I'd move my decimal place from here. I'd have to make my number between 1 and 9. So my decimal place would move 4 places to the right. So my number would be 5.8 times 10 to the negative 4 kilograms. So notice those zeros disappear. So when you put something in scientific notation, it's going to take out any of those non-significant numbers. So here, if I have 0.002, 0.0025. If I look at that in scientific notation, then that's going to, significant figures, that is 2 significant figures. And if I changed it to scientific notation, my 1, 2, 3, my decimal place would have to go 3 places to the right. So my answer would be 2.5 times 10 to the minus 3. Same thing here, those zeros out front. 1, 2, 3, 4, 5. Only the non-zero numbers are significant, so that is 5. So when looking at this, I'd have to go 1, 2, 3, 4, 5, 6. So 2.3899 times 10 to the minus 6. So the number of decimal places I had to move to the right to make my number between 1 and 9 changes it to scientific notation, and I have to use that exponent to indicate that. So anything 1 through 9, significant, always. Anything that is a 0 out front with a decimal, never significant, just showing you how small that number is. Now, zeros in between. Now, if a 0 is in between a non-zero number, then that's actually measured. So it's measured at a 0. So this would be this 0 and this 0, all of those significant. So that entire number, 1, 2, 3, 4, 5, 6, 7, 8, 8 significant figures in that one. If I put this in scientific notation, I have to keep everything. So I would have, if you don't see a decimal place, remember that means the decimal place is at the end. So 1, 2, 3, 4, 5, 6, 7. So this would be 1.2580607 times 10 to the 7th. Positive exponent because my number is bigger than 1. Now the last one, zeros that are at the end. So zeros at the end, it kind of depends. Zeros at the end depend on if there's a decimal or not. If there is no decimal, they are never significant. So for example, 12,000, just 2 significant figures. And if I change this number to scientific notation, remember the decimal would be at the end. So 1, 2, 3, 4, 1.2 times 10 to the 4th. Not significant zeros drop off with scientific notation. This one, These zeros at the end, no decimal, those are not significant. That one that's in the middle would be significant because it's between the 9 and the 3. So 1, 2, 3, 4, 5, 6, 7. So I'd have 7 significant figures, and if I wanted to put this in scientific notation, my decimal place would start on this end. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.59036.5. I would leave those last 3 off, and it'd be times 10 to the 9th. All right? So then the difference is if you have a decimal place anywhere in the number, so you could have a decimal place out front, a decimal place in the middle, a decimal place at the end, any number that has a decimal place, any zeros at the end of the number, and that those zeros could be before the decimal or after the decimal, but the key thing is they're at the end of the number. Those are always significant. So looking at these 4 numbers, that 0, significant. These 2 zeros, significant. These 4 zeros, significant. These zeros, significant. Because there's a decimal place, that indicates that those that I have measured all the way to that decimal place, to that position, so it makes these numbers much more exact than just saying 0.0021 or 12.023. I'm getting those extra zeros at the end show how far I did my measurement. So those are all considered measured values, and they end up significant. So you don't drop them off. So this would be 3 significant figures. This one, 1, 2, 3, 4, 5, 6, 7 significant figures. This one would have 6 significant figures, and this one would also have 6. So if I put this in scientific notation, I have to include these. So this one would go 1, 2, 3, 4. It would be 2.10 times 10 to the negative 4. Notice I dropped those zeros off in the front, but I do have to keep the 0 at the end. Same thing for this. This would end up being 1202300 times 10 to the 1. Kind of a waste of time to put that one in scientific notation, but same thing with this. This would be 5.81234 times 10 to the 1. And this last one, 1, 2, 3, 4, 5, 1.20000 times 10 to the 5th. Okay, so zeros that are significant are zeros in between non-zero numbers, zeros at the end of a number, anywhere at the end, if there's a decimal. But they have to be at the end, just like these 4 examples. Now, rounding. So if you round a number, I always start from the left and find the number of significant figures that I have to keep. Then you just look at the number after that, the one that is, if it is less than 5, it rounds down. If it's 5 or higher, it rounds up. So for example, with these, if I want to round these number to 2 significant figures, so 2 significant figures in this one, I need to look at, starting at the left, there's my 2 significant figures, the 1 and the 2. The next number is an 8. So that means that's going to round the 2 to a 3. So this would be 1 and a 3. Those are the 2 significant figures I keep. But do you see this number is 128? I need to add a 0 after the 3 to show that this is 130, rounded from 128, rounded to 130. This 0 is not significant, but it shows me the size of the number. It indicates where the decimal place would be. Right? So the decimal place comes after the 8. That is why I have to put that 0 to show the size of that number. So here, I go along. Remember, these zeros out front are not significant. I'm going to keep them, but they're not significant. The first 2 significant figures I get to is the 2 and the 5. Again, the next number is an 8. And so that means that 5 becomes a 6. I do have to keep those zeros, so 1, 2, 3, 2, and 6. Next one, starting from this side, the 1 and the 5. Next number is a 9, which will round my 5 to a 6. So then I've got 1, 2, 3, 4, 5 before I get to where the decimal place would be. So I would say 1, 6, 1, 2, 3, 4, 5. Yep. So this would be 1,600,000. I have to keep those zeros in because that shows where the decimal place would be. I don't add the decimal place because remember that makes it more exact. That would make all those significant. So this one, 13.00069, first two I want to keep is here. The next is a 0, so remember then these would all drop down. So I would just put 13. I don't need to put the decimal place. It's not right, it's not wrong, but if I put the decimal place, it's two significant figures. If I don't put the decimal place, it's two significant figures. So let's take these same numbers and round them to three significant figures. So again, with this, I'm going to find the first three significant figures from the left. The next number is a 3, so 364. All of those would just drop off. So I would just put 128. This one, first three significant figures I find are the 2, the 5, and the 8. Next is a 0, so I know those will just drop off. I do keep those zeros out front, because those show where my 2, 5, and 8 are in terms of their decimal position. So 0's out front, but the 2, 5, 8 is my significant figures. Next one, 1, 2, with a 1, 5, and the 9. Next number is a 6. So that means now I have a 1, 5, 9. Whoop, next number rounds up, so my 9 rounds. So now I'm going to end up with 160, 160. And then I have 1, 2, 3, 4 zeros. 1, 2, 3, 4 more zeros. So this one's a bit of a challenge. I guess I didn't really look at this one so closely, but in this one, I would, in true math form, I would actually put a line over that 0 to show three significant figures. For us, you're not going to really see that, but that would show that this one is significant, but these other zeros are not. If I was going to put this in scientific notation, though, I would put 1.60 times 10 to the 1, 2, 3, 4, 5, 6, 10 to the 6th. So that would really be like the correct way to show significant figures. In this one, three significant figures rounding. So the 1, the 3, and the first 0 I would keep. All the rest of those would drop off. So this would be 13.0. So now let's take these same numbers and let's round them to 4. 4 significant figures. I'm starting from the left, underlining the first 4 I come to. Next number is a 6. That's going to round the 3 to a 4. So this would be 128.4. 4 significant figures in my answer. So here I have the 2, the 5, the 8, and the 0. So I'm going to keep those zeros out front. The next number is a 6. It would round my last. This 0 would round up to a 1. So 0.00025881. Next one, 4 significant figures here. Next is a 4, so those would round down. So 1596123. This one, 4 significant figures here. 13.00. Next is a 0, so that all rounds off. And so it would end up being 13.00. Okay, so that's just rounding. Now, you've got to be able to apply this rounding. So remember, if you multiply or divide, your answer needs to have the same number of significant figures as the smallest number of significant figures in the measured values. So in this first one, 1, 2, 3, 4, 5, 6. This is 6 significant figures. In this one, this is only 3 significant figures. So I know my answer has to be rounded to 3. This one only has 3 significant figures. This one, 2 significant figures. Tells me how to round. 120 has 2 significant figures. 5.8, 2 significant figures. This one, 3 significant figures, 4 significant figures. And the last one, 12.03, 4 significant figures. 9 has just 1 significant figure. So in each case, do the math first. Do not round first. Do the math first and then round. So just put these in your calculator. So 2.368, hold on, I'm going to turn on the calculator. 2.36840 times 12.0, and I end up getting 40.4208. I've got to round this to 3 significant figures. So 40, I'm going to start here. So the 404, next number is a 2, it rounds down. So 40.2, or sorry, 40.4. 40.4 is that answer. Next one, 0.265 divided by 0.265 times 0.12378 ends up being 0.0002067. Just doing the math. Now when I get done, 3 significant figures, 2 significant figures, so I know those are the 2 significant figures I got to keep. So the next number is a 6. It would round that 0 up to a 1. I have to keep those zeros out front because remember they show you how small those 2 and 1 values are. 120 times 5.8, 696. So this, rounding to 2 significant figures, see there's the first 2 significant figures. So the 6 rounds the 9 up. So this ends up being 700. So if I wrote 700, that would be fine. If I was going to put this in scientific notation, then I could indicate the 2 significant figures that I needed to have because that first 0 would be considered significant. I'd be fine if you had 700 because it's still going to be the right number of units. So now dividing 0.0365 divided by 0.3589, my number ends up with a lot of decimals, 0.101699638. Okay, when I look at it, I see that I've got 3 and 4. So there, I have to have 3 significant figures. So the 101, next number is a 6. So this would round up to 0.102. Last one, 12.03 divided by 9. 12.03 divided by 9, and I get 1.33666667. Okay, all the way across. Looking at my answers though, 4 significant figures and 1. So the next number is a 3, so this would just be a 1 as an answer. Okay, so I hope that this helps in terms of significant figures and rounding and this practicing. I do encourage you to try and do that dynamic study module on significant figures. I think that it helps too, but hopefully this kind of helps things to pull in a little bit more and just help you to think about significant figures as being a measured number and then making yourself these rules for what you do with those zeros.